these are the notes for section 2.1 in our statistics course. This section is about just basic taking data and making graphs out of them. How do you visualize a data set, things like this. And so let's jump right in. A frequency distribution is just a table that shows how you've chunked your data and a count of number of entries in each class. Now, you'll see exactly what I mean by that when I do an example. But statistics is all about counting how often an observation occurs, usually within maybe a time interval or at least I shouldn't say usually, but quite often in a time interval, but also taking just raw numbers and saying, where are these numbers mostly clustered around? So if I was measuring body weights of human beings, your weights are going to generally be, I don't really know much about weights, but let's say between 150 and 250 pounds. I think most people are in this range. That doesn't say that there aren't very lightweight people, and like children, for example, or extremely heavyweight people. This happens, but your statistical analysis is merely a way to understand how the data is distributed. What is most common, things like this. Because if you want to adapt, say, a strategy for making people healthier, you want to know sort of your target audience, and statistics can help you determine that. So we need two ideas to make a frequency distribution and to make a histogram. First is what's called the range, and the range is just of all your data points, which one's the biggest, and I subtract from that, from all my data points, whichever one is the smallest. So this is just the distance between the smallest data point and the largest data point. The class width, and what I mean by class is, if I have a data set and it's going to be convenient for me to chunk it into 4 classes of numbers, I can do that. Or if I wanted to chunk it into 8 classes or 12 classes or whatever, I generally want the classes to be evenly spaced, and I want them to not cover ranges that aren't useful for my data set. So that's why on top we put the range, and on the bottom we divide by the number of classes. And just to make everything nice and integer based, that way we round this number up, and that's our data range. Now occasionally you'll find that some of your data points will fit into 2 classes. Our textbook takes the opinion that to maybe alleviate this, you should make sure your ranges go to halfway between 2 numbers. I don't care so much about that. For my purposes, I think that if you just stay consistent with how you're counting things, everything will be fine. So, if you have something occurring at an endpoint of your class, and you always put it in the smaller class, then that's okay. We will find that won't matter a huge amount later on. So, with this, what we call the frequency distribution, this is a table of values. We also have the frequency histogram, which is how you visualize this frequency distribution, and it's just a bar graph. So let's look at an example. So this is problem 31 from section 2.1. It asks us to create a frequency distribution and to create a frequency histogram with 6 classes for the following set of sales in dollars for sales at some company. So, each data point here is representing total amount sold, I guess in a day, maybe. It's not very clear, but total amount sold, let's say in a day, at this company. And so we have these numbers. Now, just as a list here, it's kind of hard to sort of understand this number set, which is why we have statistics in the first place. So let me show you.
If I have customers in the boarding area, last name Ellie, E-L-Y, last name Olive Murphy, final destination New York LaGuardia, can you please see me?
Okay. So let's try to make this distribution in this histogram. So what I do is I put the data into a spreadsheet. Now here I'm using the spreadsheets provided by Google Docs, and that's for a couple of reasons. One, I'm using Linux on my laptop, and so I do not have Excel. And two, I tried to use the online Excel provided by the university, but it's a very restricted version of Excel that doesn't have all the features we need. So I hemmed and hawed about this and decided that Google Sheets will work, but you're certainly welcome to use whatever spreadsheet program you wish. If you're a programmer and you know how to use R or Python or Pandas, please feel free. I'm certainly welcome to help you with maybe doing this in a programming language if you want to do that, but a simple spreadsheet program will get the job done. Although every spreadsheet program is a little different, so if you're having trouble, please let me know. Okay? So again, we want to put this data into the spreadsheet, so I will put them in one by one. So this will be a little boring. 2114, 2468, 7119. It's probably a little easier if I make the window smaller. I drag it over here, and then I don't have to keep going between two windows as much. 7119, 1876. And by the way, the order that we put these in does not matter. So we will end up sorting them anyway. So just get them in there any way you want. If you happen to be able to copy paste them, wonderful. Maybe when I'm writing problems for you, I will make a data file for you that's already sort of as a spreadsheet sometimes. That will make things a little easier for you when you're doing these problems. But if I'm giving you a book problem or something, then those are on paper, and so you just have to suck it up and type them in. But there we go. That wasn't so bad. Now this thing says create a frequency distribution and a frequency histogram with 6 classes. So if we look back at our formulas, the class width is what we're going to use to chunk our data into these classes. And so first thing we have to do is find this class width here. But that requires us to know the range and the number of desired classes. Well, our problem says that we want 6 classes total, right here. So we know the denominator of this fraction, but we don't know the numerator yet. So what I will do is I'll have to find the range. To do that, I need to find the largest and the smallest data points and subtract them. Well, one way you can do that is just to look at all the data points and figure it out. But that's kind of inefficient. So what's easier is just to sort your data. Now, every spreadsheet program is different, like I said. But in this case, on Google Sheets, if I sort the range, I think that's what I want. There we go. So the smallest data point's at the top, the largest is at the bottom. So my range is going to be, and by the way, when you type in Google Sheets or Excel or anything, if you want to input a formula, you put an equal sign in a box. And in this case, I want to subtract this value, and notice it's orange when I clicked it, and it's orange in the text box as well, and I want to subtract from that the smallest data point. And I'll click that, and it gives you a different color, which is kind of helpful sometimes to figure out what's going wrong if you type something incorrectly or something. So my range is 6119. So now I can find my class width. My class width is going to be my range. So again, I put an equal sign for a formula. My range, so I clicked this, and they told me I had 6 classes they wanted me to have. So I divide by 6, and I get this number 1019. But then it says round up. So I'm going to round that up to 1020. And I don't even worry about rounding down or anything, just round up. Now, what this tells you is that you want the width of your classes to be 1020. And what do I mean by width? So when I chunk this data up, I'm wanting to chunk it up into like 6 evenly spaced, I want to chunk the possible values into 6 evenly spaced classes, and then I want to see how the data fits into them. So my smallest data point's 1,000, and I want everything from 1,000 to 1,000 plus the class width in my first class. So 1,000 plus 1,020 is 2,020, and I want 6 of these. So my first class is going to be data points in this range, and if you look at your data set, in this case, there's a good bit of them. I mean, all of these are going to be in this class range. But this next point, 2,468, is not. So it would be in the second class. But the second class will start where the first class left off at 2020, and now you see this endpoint issue that I brought up earlier that could happen. You know, if 2020 was a data point, we have to decide which class it goes in, or alter our classes so that it's not a problem. I'm going to kind of not worry about that a lot. Instead, I just want to worry about actually making the classes and finding the frequency distribution. So again, our class width's always 1,020, so the right endpoint of this class is going to be this 2020 number plus 1,020, which will give us 3,040. And let's just get all our classes together right now. So the next class will start at 3,040. I add 1,020 to it, I'll get 4,060. Then I start at 4,060, I add 1,020 to it, I get 5,080, and that's 4 classes, so I need 2 more. 5,080 goes to 6,100, right? And then 6,100 goes to 7,120. So these are my 6 classes. I find it useful sometimes just to put at the top what I'm talking about here. And now what we're interested in is finding the frequency of the data set within each class. So my interest here is to count, and notice I put equal and I put count, and this is a function, and it's going to count everything I highlight. So I just want to highlight everything from 1,000 to 2,020. And so that's all the points that are in this class. And having our data ordered makes this a little easier. Now you could just count them by hand and put the number in, but why work harder? Work smarter. So let's count now everything between 2020 and 3040. So that'll start here, and it will go only 2, these 2. Now let's count everything 3040 to 4060. 3040 is smaller than 3,183, so we'll count everything up to 4060, which will take me, 4,105 is not smaller than 4060, so again I'll get 2 here. Now I need everything from 4060 to 5080, so I'll start here and I go up till I reach until I reach things that are not smaller than 5080. So I'll go up to this point, because 5,839 is very large. Between 5080 and 6100, there's just 1. It's just this point here at 5835. And finally, the last bit, there's also 1, because that's what's in there. So this thing all together is called our frequency distribution. And you see it's very dependent on the number of classes. So if I was a little more granular and I said, maybe I want 10 classes, then these numbers would be a little different, but I might end up with situations where there's gaps where I don't have anything in it at all. So there's an art to picking the number of classes that you want, and it's usually about what makes the data look good. So in this case, 6 classes work pretty well because every data set had something in it. There's nothing we can do about the fact that the data was weighted more towards these first kinds of classes than later on. That's just how the data is. But based on our choice of number of classes, we got a nice looking data set. So that's what a frequency distribution is. It's a table that shows a count. So we literally used the function count when we did it, of the number of data points in each class. That's what we've done. So histogram is the idea that we will take these classes, and at least in Google Sheets, if you highlight both, go to Insert, and it's a little different in Excel. I'll click Chart, and I'll just click. I want to create a bar graph, and look, it did it automatically. This is a histogram. And all it is the bar graph of your frequency distribution. So the classes are your x-axis, and the heights of the bars are your frequency counts. Now, Google Sheets also can make histograms automatically, but in some of the homework assignments I'll ask you to show me the frequency distribution, so you're not going to avoid doing this class stuff in the first place.
Good afternoon, ladies and gentlemen. Welcome to JetBlue Flight 1486 with service to Boston. My name is Ryan. I'll be working your flight this afternoon. Just want to share an update with you. First off, we are operating on a delay this afternoon, so we do apologize for that. Your aircraft is coming in from Boston. Had a minor maintenance issue pop up. They were able to resolve it very quickly, though. It is currently in the air on its way here at this time. We're expecting your aircraft here at the gate right about 1 o'clock, so a little less than an hour from now. When that aircraft gets here, it takes us about 30 minutes to turn it around, get everyone on board, and get you on your way to Boston. So we're looking at about a 1:38 departure this afternoon, put you in Boston right about 3 o'clock. A few minutes after 3 o'clock, 3:05 is the estimated arrival time into Boston today. We do have a good amount of connections on this flight. All connections are good at this time, with the exception of those going to New York's LaGuardia Airport. So if LaGuardia is your final destination today, please see me at this time so we can look into your flights and everything. Once again, aircraft will be here just a little less than an hour, right about 1 o'clock. Should have you on your way about 30 minutes after that. 1:38 is our delayed time right now. We apologize for the inconvenience. We are here to assist you, so if you have any questions at all, please see me. I'd be happy to assist you. Thank you.
Okay, so that was that example. The other important thing in this section is a relative frequency histogram and a cumulative distribution. And what this is going to do is it's going to take our data set and we do what we call normalization. It's going to put everything in terms of probabilities, which is a big part of this course. So all you have to do to create a frequency histogram is to take your frequency distribution that you've already created, and then all you do is you divide each value in your count by the total number of data points. We call that the sample size of the data set, and that's it. I mean, that'll give you always numbers between 0 and 1, and they have the nice property that when they are summed, they sum to 1, and that's by design. Now, a cumulative frequency graph, all you do is you make a graph of your frequency value, relative frequency values. Generally, these are drawn as line graphs, so we will be doing that as well. So let's do the same example, but let's make a relative frequency histogram for it and the cumulative distribution and plot that thing and see what it looks like. So these are my frequencies, my frequency count, and what I need to do is I need to find out how many data points I have total. That's in my original data set. How many data points do I have total? Well, we know how to count. I guess you could look at the numbers on the left, but maybe your data set's not just vertical. So just highlight your data set, put it in the count function, and we end up with 22. So if I want to find the relative frequencies, I want to divide each of these values by 22. The way I pull that off is I want to do a calculation, so I'll put an equal sign in this box, and I'll click this, and that'll make that cell what I'm calculating, and I'm just going to divide that by 22, and I get some number. Now I can do that over and over again in each cell, or I can make it easier on myself and take this little square in the bottom right corner, click it, and drag it down. Now what that does, now if you look up here, you see the formula that's going on in a certain cell that you've highlighted. So, if I highlight this cell, this is telling me I've taken the D4 cell, I've divided it by 22. And by dragging it down, what has happened? Well, I'm always dividing by 22, but notice that in this little formula box, D4 has become D5, has become D6, become D7, and what this means is that it's kind of just making the same calculation as I did it, following my pattern. And that's great. that is exactly what I wanted it to do. So spreadsheets make this easy for you. And that's great. So our relative frequency distribution is our classes with these relative frequencies. So if I ask you to give me a relative frequency distribution, that's what I want. But this problem also asks us to find a cumulative distribution and a cumulative frequency graph. So a cumulative distribution is what we get when we sum the values in this. And I don't mean sum all of them at once, but I mean sum them up, as I go along. So the first value on my cumulative distribution is the first value of my relative frequency distribution. Nothing different there. The second value of my cumulative distribution is going to be the first value plus the second value. And so I'll get a strictly larger number. Now, let me show you how you can automate this so you don't have to type it a bunch. So what you can do is you can type sum, and we're doing another function, and I want to sum from a point, a cell E4 to the cell E4. Now, if I just took this and I dragged it down, what it would give me is the sum from E4 to E4, and that is just adding this one cell to itself. And if I dragged it down, it would sum E5, E5, E6, E6, and I don't want that. I want it to sum from this cell downwards. And the way we tell the spreadsheet to do that is with dollar signs. So dollar signs have the property that when you drag it down, it will keep what's by dollar signs the same. So the dollar sign before the E is saying, don't change this E. And the dollar sign before the 4 is saying, don't change this 4. But I don't want to put them there. I want to put them at the starting point. Apologize for that. So let's put them here. And so when I sum, I want to sum from this value to this value and this value as I go down. So this will accomplish that. And you'll see that the same value we had here earlier is still there. So this works as expected. And so these numbers are giving us what's called the cumulative distribution. And all we want to do now is draw the cumulative, what do we call it? The cumulative frequency graph. So to do that, highlight this and highlight this. And to do that, hold the control key, and that'll let you highlight both. Then I will insert, and you could also just put the classes over here and do it that way. But I'm going to insert a chart. And I don't want a bar graph, I want a line graph. So find the line graph button, and there we go. That is our cumulative distribution. That's not how we want to do it. We don't want to put the classes in there. I apologize. What we want to do is we want to put the frequency count. No. Yeah. I think it's probably nicer if we take the cumulative distribution and we just put numbers here. So I don't want to lead you astray and say that the classes are the variable of this function, because they're not. But it's quite often just take these integers as their values. It'll look better that way. So the graph is going to look the same, but the x-axis will look a little different, and that's okay. Now notice here that it's plotting two things, and I don't want it to do that. I want the x-axis to be these values here. So sometimes you have to alter things to behave the way you want. Now I don't want this B4 to B9. That's these parts here. I don't want those to be in my what's called the series, which are the y values. So I'm going to delete that, and now I have exactly what I want. My x-axis are the numbers 1, 2, 3, 4, 5, 6, corresponding to my classes, my 6 classes, and the y values are coming from this cumulative distribution column, and that's what we mean by a cumulative frequency graph. Now, the interplay between a histogram, this bar graph thing, and this line graph here, this cumulative distribution graph, is a big part of statistics. We will do a lot with how these two interplay with each other, and in an advanced statistics course you find that they're related by basic calculus. In fact, if you know a little calculus, it turns out that your histogram is similar to the derivative of your cumulative distribution. Derivative being a calculus term. We don't need that in this class. Calculus is not used in this class, but for those who have had a little bit, I mean, that's how these are related. And in an advanced statistics course, you would talk a lot about that. Okay, I think that's it for this section.